Hello everyone. In this video, we are going to discuss about normal forms in DBMS. A normal form is a set of progressive rules which are needed, which focuses on reducing data redundancy and anomalies. Data redundancy means duplicate data which are present in the database. And the second one is anomalies. Anomalies consist of mainly three different types. First one is insertion anomaly, second one is deletion anomaly, and third one is updation anomaly. The normal forms focuses on reducing these data redundancy and anomalies. So in this video, we are going to discuss about 1NF, 2NF, 3NF, Boyce Court normal form, 4NF, and 5NF. Let us look into the first one, which is first normal form. A table is in first normal form if it satisfies the following conditions. It should have only atomic values, and second one is each row must be unique. So let us understand the 1NF with a clear example. If a table has a column phone numbers, a person can have multiple phone numbers, which violates the first normal form. In this first normal form, we have all columns must contain only atomic values. Means a person should have only single phone number or a single value to satisfy the first normal form. Having multiple phone numbers violates the first normal form. So this is about first normal form. Now let us look into the second normal form. A relation is in a 2NF if it satisfies the condition of 1NF and additionally no partial dependency exists. So what is a no partial dependency? Means every non-key attribute must depend on entirely primary key attribute. So consider this image where we have four different fields or columns. In this roll number is a primary key attribute. Remaining name, branch and languages known are non-primary key attributes. So in 2NF, every non-primary key attributes like name, branch and languages known, these attributes should be dependent on primary key attribute, which is roll number. So here a name depends on roll number, whereas a branch and languages known does not depend on roll number. So after this image is converted into a 2NF, it looks like this. See, here roll number is a primary key where name and branch are dependent on a primary key. Where primary key should contains unique value and it should not be null. Similarly, a second table is formed with the languages known and a roll number. Here a roll number is not a primary key attribute. This is a separate table and this is a separate table. So this is one example. Now let us consider a second example. For a composite key, student ID and course ID, two composite keys. If a student name depends on only student ID and not on entire key, it violates 2NF. To normalize, move the student name into a separate table where it depends on a student ID. So let us understand this. We have a relation consisting of three values. First one is student ID, course ID, and student name. The student name depends on student ID, but it does not depend on course ID. So we are creating a separate table with student ID and student name, and separate table with student ID and course ID. So this is about 2NF. Now let us look into the third normal form. A relation is in 3NF. If it should be in 2NF and additionally no transitive dependency. So what is a transitive dependency? No primary key attribute or no prime attributes should not depend on other primary key attributes. For example, consider a table with student ID, course ID, and instructor, three different values. If instructor depends on course ID and course ID depends on student ID, then indirectly instructor depends on student ID. So this violates the 3 NNF. To resolve this, we will place a student ID and instructor separately and the student ID and course ID separately. So this is first example. Now let us consider the second example, which is in the image. Let us consider four fields. We have name, branch and fee as non-primary key attributes or non-prime attributes. Roll number as a primary key attribute. Here branch and name depends on the roll number, but the fee does not depend upon the roll number because depending upon the branch the fee varies. For CSC the fee is 30,000, AML the fee is 20,000, and similarly with DS and DCE. So to convert this into the 3 NNF, to convert this table into the third normal form, we split the tables into two parts. The first table consists of a name, roll number, and branch. Roll number as primary key attribute, and the second one consists of branch and fee. So, by converting into two tables, it satisfies the third normal form. So, this is about third normal form. Now, let us look into the Boyce chord normal form or BCNF. BCNF is a strict version of a 3NF where for every non-trivial functional dependency x depends on y, x must be a super key. For example, let us consider this image first. This is the table student. It consists of four different values. First one is roll number, student name, branch ID, and branch name. Here, roll number is only the primary key, whereas the student name, branch ID, and branch name are non-primary key attributes. So, according to the Boyce chord normal form, it should be in 3NF as well as if x depends on y, x must be a super key. Let us consider x. Let us consider a roll number as x and student name as y. So if student name depends on roll number because for Sai roll number is 1, Shiva roll number is 2. So student name is depending upon the roll number. So roll number must be a super key. Similarly, consider branch ID and branch name. Depending upon the branch name, the branch ID is assigned. So branch name is depending upon the branch ID. But here branch ID is not an primary key or sorry super key. Here super key means every value must be unique. See here there are two CSEs 121 and 121. So this violates the Boyce chord normal form. So by converting this image into the BCNF, we create two different tables. First one is roll number and student name. The second table is branch ID and branch name. So this is about Boyce chord normal form. It should be in 3NF as well as non-trivial functional dependency. Means y depends on x such that x is the super key. Now let us look into the fourth normal form. A table is in fourth normal form if it is in BCNF as well as a non-multi-value dependency. For example, let us consider this image. This image consists of three fields. First one is student ID, course, and hobby. Here, student ID is a primary key, whereas course and hobby are non-primary key attributes. So, by converting this into the fourth normal form, it should be in BCNF as well as it should have no multi-value dependency. By converting this into the fourth normal form, this table, it forms the two different tables. First one is student ID as well as course. And the second one is student ID as well as hobby. So this is about fourth normal form. Let us look at the last one, which is fifth normal form. Fifth normal form is achieved if it is in fourth NF as well as joint dependencies. So what is meant by joint dependencies? Joint dependencies means uh, fully decomposing the table into the smaller tables. So let us consider two examples. If a table contains student ID, course and instructor, and there are dependencies where all combinations of these columns are needed for a specific relationship, you must split them into smaller tables to remove redundancies. So we have a table with student ID, course and instructor. To convert this into the fifth normal form, we divide it into smaller tables. The first table consists of student ID and course. Second table consists of a course and instructor. And the third table consists of a student ID as well as instructor. So this is first example. Now let us look into the second example in detail. In the second example, we have three fields. First one is subject, faculty as well as year. To convert this into the fifth normal form, we divide the entire table into the smaller tables. So look into this. We have three tables formed. First one is with subject and faculty. Second table consists of faculty and year. And the third table consists of subject and year. So you guys can have a doubt like what is the difference between the fourth normal form as well as fifth normal form. See here in fourth normal form, we use primary key to divide the remaining non-primary key attributes. In the splitted tables, we have primary key in every table. Here student ID is the primary key. But in fifth normal form, there is no primary key. There is no concept of primary key. The entire table is divided into as many as tables. So this is about the normal forms. Thank you for watching. Please like, share and subscribe. If you have any doubts or feedback, please comment below. Thank you.